Hello everybody, I'm Suman Matthews and the topic which I will be talking about today is correlation. This would be useful to students of grade 11 maths and students who are studying statistics and maths at the college level. I have been teaching mathematics for the past 25 years and in this video we will be illustrating simple methods of calculating correlation and covariance, and different types of problems using different formulae are discussed. So watch the entire video with me, take a pen and paper and work with me. Correlation is used to measure the degree of variations in two variables. And we first define covariance between two variables x and y as summation x minus x bar into y minus y bar by n. This is defined as 1 by n summation xy minus 1 by n summation x summation y. When you simplify it, you get this. Karl Pearson's coefficient of correlation is defined as R, which is covariance of xy by sigma x sigma y, where sigma x is the standard deviation of x, sigma y is the standard deviation of y. R is also defined as n summation xy minus summation x summation y by square root of n summation x squared minus summation x the whole squared into square root of n summation y squared minus summation y the whole squared. If R lies between 0 and 1 by 4, R has a low degree of positive correlation. If R lies between 1 by 4 and 3 by 4, R has a moderate degree of positive correlation. If R lies between 3 by 4 and 1, R has a high degree of positive correlation. If R lies between minus 1 and minus 3 by 4, R has a high degree of negative correlation. If R lies between minus 3 by 4 and minus 1 by 4, R has a moderate degree of negative correlation, and if R lies between minus 1 by 4 and 0, R has a low degree of negative correlation. R is also defined as summation x minus x bar into y minus y bar by root summation x minus x bar the whole squared into root summation y minus y bar the whole squared. For large values of x and y, we let A be the assumed mean for x, B be the assumed mean for y. We let u be equal to x minus a, v be equal to y minus b. So R equal to n summation uv minus summation u summation v by root n summation u squared minus summation u the whole squared into root n summation v squared minus summation v the whole squared. And R squared lies between 0 and 1. With these formulae, we'll come to problems. Find R if covariance of xy is minus 16.5, variance of x is 2.25, variance of y is 144. Now R is defined as covariance of xy by sigma x sigma y. Sigma x is square root of variance, that is 1.5, sigma y is 12. So when you substitute, you get R as minus 16.5 by 1.5 into 12, which is minus 0.92. If n equal to 10, summation x is 36, summation y is minus 27, summation x squared is 226, summation y squared is 267, summation xy is 7. Find the correlation coefficient. Here we make use of the formula R equal to n summation xy minus summation x summation y by root n summation x squared minus summation x the whole squared into root n summation y squared minus summation y the whole squared. N is 10, so that would be 10 into summation xy is 7 minus summation x is 36, summation y is minus 27. So I get 36 into minus 27. And substituting the other values, you get root 10 into 226 minus 36 squared, root 10 into 267 minus minus 27 squared. So R would be 0.76. Question 3. The coefficient of correlation between two variables x and y is 0.64. Their covariance is 16. Variance of x is 9. Find the standard deviation of y. Here we use the formula R equal to covariance of xy by sigma x sigma y. R is 0.64, covariance is 16, sigma x would be square root of variance, which is 3 into sigma y. So simplifying we get sigma y is 8.33. Question 4. Find the covariance and the coefficient of correlation between x and y when n is 10. So summation x is 60, summation y is 60, summation x squared is 400, summation y squared is 580, summation xy is 305. So to calculate the covariance, we use the formula 1 by n summation xy minus 1 by n summation x summation y. That would give you minus 5.5. And coefficient of correlation, we use the formula n summation x squared, that is n is 10, summation xy is 305 minus summation x summation y, that is 60 into 60 by root of n summation x squared minus summation x the whole squared into root of n summation y squared minus summation y the whole squared. So we get it as minus 0.5863. Question 5. Calculate coefficient of correlation for the following. N is 10, summation x is 100, summation y is 150, summation x minus 10 the whole squared is 180, summation y minus 15 the whole squared is 215, summation x minus 10 into y minus 15 is 60. So here x bar would be summation x by n, which is 10, y bar would be 15. We use the formula r equal to summation x minus x bar into y minus y bar by root summation x minus x bar the whole squared into root summation y minus y bar the whole squared. Summation x minus 10 into y minus 15 is 60. So it would be 60 by root 180 into root 215, which is 0.305. Question 6. We have a table here. Calculate Karl Pearson's coefficient of correlation. We take the sales in lakhs as the x values, expenditure in lakhs as the y value. Since the value seems somewhat large, we can take the assumed mean as u as x minus 23, that is 135 by 6, which is close to 23, v equal to y minus 28. 165 by 6 would be a number close to 28. That is how we choose the assumed mean for x and y, a value close to the means. So we have the sales, expenditure, u is x minus 23, v is y minus 28. We calculate uv, u squared, v squared, take the sum. So r is given by n summation uv minus summation u summation v by root n summation u squared minus summation u the whole squared into root n summation v squared minus summation v the whole squared. This would give you n is 6. So you will get 6 into summation uv is 38 minus summation u summation v, that is minus 3 into minus 3, and so on. Substituting the other values, you get the value of r as minus 0.68. For more videos on statistics, subscribe to my channel or my playlist.